Hello everyone, this is our 6th educational based video. In this video we are going to learn about a topic from the subject engineering mathematics. This topic is common for the all branches of engineering for a degree course. So this topic name is Laplace Transform. We'll see the different types of formulas in this particular module. The first formula says Laplace of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. This is the definition formula. So let's see the questions first. Find the Laplace transform of f of t where f of t is equal to t for 0 less than t less than 4 and f of t equal to 5 for t greater than 4. So first we will write down the basic formula. Now the limits are from 0 to infinity and we have been provided with two regions, that is 0 to 4 and then greater than 4, that means 4 to infinity. So we'll divide this region into two parts, 0 to 4 same function and 4 to infinity again the same function. Now this formula for 0 to 4 in the question we have been provided the value is f of t is equal to t, and for integration from 4 to infinity the value has been provided as f of t equals to 5. Okay, so we will do the integration by parts. So in this integration by parts we will do, first we will assume this t as function u and e raised to minus st as function v. So the formula says u integration of v dx minus double integration of v into derivative of u. So my u is t, so I'll write down as it is. Integration of e raised to minus st would be e raised to minus st upon minus s, then 2 times integration would be e raised to minus st upon s square, and derivative of t with respect to t would be 1. The limits are from 0 to 4. Then for integration 5 is the constant, and again integration of e raised to minus st is e raised to minus st upon minus s, and the limits are from 4 to infinity. When we put the limits, what we are getting is minus 4 by s e raised to minus 4s, that is the upper limit for this. Then minus 1 upon s square, when you put upper limit over here you get this function. When you put lower limit you get 0 over here, so we don't have to write down. And when you put 0 over here, e raised to 0, that is 1, so 1 upon s square, and minus, and again lower limit minus, you get plus sign over here. And then when you put integration upper limit over here you get e raised to infinity minus infinity, that would be 0, and this minus and lower limit of minus for this 4 value you get e raised to 5 by s e raised to minus 4s. So your final answer is 1 upon s square plus 1 by s minus 1 upon s square e raised to minus 4s. That is our first question. Okay, now let's start with the second question, that is find the Laplace transform of f of t equal to cos t for limit 0 less than t less than pi and f of t equal to sin t for t greater than pi. So we'll write down the basic formula. Then we have two regions, that is e raised to minus st for 0 to pi cos t dt and pi to infinity e raised to minus st for for pi to infinity you have in question it is sin t, that is t greater than pi, that means pi to infinity. So first of all you have to learn these two basic formulas which we have explained in our integration formula video. So integration e raised to ax cos bx dx gives you 1 upon a square plus b square e raised to ax into a cos bx plus b sin bx, and if you have in the same integration sin bx then you have the same formula, it's just that these two things are same. A as it is, instead of cos bx you have to get sin bx, sign changes, and instead of sin bx you have cos bx. Now Laplace of f of t equals to, now what we will do, we will just do the integration as of previous formula. So e raised to minus st into minus s cos t plus sin t, we will put the limits, same here we will put the limits again, that is e raised to minus st minus s sin t minus cos t for pi to infinity. Now when we put these limits, what we are getting is 1 upon s square plus 1 e raised to minus pi s, that is upper limits, and lower limits we will put same we will do over here, and we get the final answer as 1 upon s square plus 1 s plus s minus 1 e raised to minus pi s, because when you put e raised to infinity you get 0. So when you put upper limit you get here as e raised to minus infinity, wherein you get e raised to minus infinity as 0. So this whole bracket you get 0, so you have to put just upper limits. And about the e raised to 0, anything raised to 0 you get 1. So this is our final answer. Okay, this was the basic definition question. Now you have to learn few formulas to be good, to get good score in Laplace transforms. So in this list of transforms, first formula is Laplace of e raised to at, that is 1 upon s minus a. Laplace of e raised to minus at is 1 upon s plus a. Laplace of sin at, you get a upon s square plus a. Then we have Laplace of cos at as s upon s square plus a square, wherein Laplace of sin at was a upon s square plus a square. Okay. Then Laplace of sine hyperbolic at, see here a and s is the difference, and in hyperbolic there is only difference of plus and minus. Okay. Next set of formula is Laplace of t raised to n, that is gamma n plus 1 upon s raised to n plus 1 if n is in fractions, and Laplace of t raised to n is n factorial upon s raised to n plus 1 if n is a positive integer. Then Laplace of 1 we get as 1 upon s. Laplace of this ERF means error function, root t is equal to 1 upon s root s plus 1, and Laplace of error function to the base c root t, you get 1 upon root s plus 1 into bracket in the denominator itself root s plus 1 plus 1. So this is all about our set of formulas for Laplace. Now using these formulas we will see the next question, that is find the Laplace transform of 4t square plus sin 3t plus e raised to 2t plus cos h square 4t, then plus bracket sin 2t minus cos with the bracket whole square. So we'll just apply a Laplace formula over here. 4 is constant state is outside, then Laplace of t square, Laplace of sin 3t, individual Laplace we are applying, Laplace of e raised to 2t, then what we will be doing for cos h square 4t is we'll substitute it as 1, this is the formula 1 plus cos h 8t upon 2. So it is Laplace of half into 1, then half Laplace of cos h 8t. For this sin 2t minus cos 2t the whole square, what we will get, a minus b the whole square, a square plus b square minus 2ab. So a square plus b square, that means sin square 2t plus cos square 2t, the value would be 1 minus 2ab, that is minus 2 sin 2t cos 2t. So individual Laplace when you apply, it is Laplace of 1, and 2 sin theta cos theta is sin 2 theta. So here it would be Laplace of sin 4t, 2t into 2t. Okay. Now when you apply this formula, what you get, Laplace of t square is 2 upon 4 was outside, 2 upon s cube. Then by this formula what we had, see this is the formula what we have learned about this formula. Okay, in factorial upon s raised to n plus 1. So same formula we are applying over here. Then this is for Laplace of sin 3t, it is a upon s square plus a square. Laplace of e raised to 2t is 1 upon s minus 2. Then Laplace of half will be as it is, 1 is 1 by s, half again Laplace of cos h 8t is s upon s square minus h square. Now Laplace of half into 1 is 1 by s, Laplace of cos h 8t we had, so it is s half into s upon s square minus h square, as we had half as constant. Then again Laplace of 1 is 1 upon s, and then we had Laplace of sin 4t, which is 4 upon s square plus 4 square. So we get this finalized answer as 4 to the 8 by s cube, 3 upon s square plus 9, 1 upon s minus 2, half upon 1 upon 2s, s upon 2 into bracket s square minus 64, 1 upon s, and 4 upon s square plus 60. Now our next question is find the Laplace transform of sin raised to 5t. Now basically we don't have any formula for sin raised to 5. So what we have to do, we have to first simplify the sin raised to 5t as e raised to it minus e raised to minus it upon 2i and then whole raised to 5. Now we have to expand this as binomial expansion. So what we get, 1 upon 2i bracket raised to 5, that is 1 upon 2 raised to 5 is 32 and I raised to 5 is again I. Then first function raised to highest power minus, there is a formula for 1 minus or x minus a raised to n. By that formula of binomial expansion we get this particular expression. Then what we have to do is we have to just take out the constants, I mean the similar terms common. So e raised to 5it and e raised to minus 5it, similarly we will take 3it with minus 3it and it with e raised to minus it. To simplify this formula, what we are doing is we are taking 2i in the denominator, so the outside constant would be, it becomes 1 upon 16, and then we are getting these 3 terms. So these 3 terms are nothing but sin 5t, sin 3t and sin t. So basically Laplace of sin raised to 5t would be 1 by 16 to Laplace of this individual terms. So when we take individual Laplaces by the previous formulas which we have seen, we are getting 5 upon s square plus 5 square, 3 upon s square plus 3 square, and 1 upon s square plus 1 square with the constants as it is. And when we simplify, I mean when we take squares, we get this finalized answer. Okay, now let's see some miscellaneous examples wherein the question says find the Laplace transform of following, which is sine root t. Okay, so let's see the solution. So to find out to Laplace of sine root t, first of all we will write down series of sine x, which you have learned in your school life, that is x minus x cubed by 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial plus so on. So if we write down the same series in root format, so what we would get, instead of x you have to just replace root t, or I can write down t raised to half. So this is the series which I get, t raised to half minus t raised to 3 by 2 upon 3 factorial, factorial won't change, plus t raised to 5 by 2 upon 5 factorial minus t raised to 7 by 2 upon 7 factorial plus so on. So when I have to take Laplace of this sine root t, I have to take individual Laplaces for this whole series. So when I take this Laplace, now we have learnt a formula previously, that is when Laplace of t raised to n is gamma n plus 1 upon s raised to n plus 1 when n is in fraction. So when we use the same formula over here, what we would get gamma n, that is half plus 1, that is 3 by 2 upon s raised to n plus 1, that is s raised to 3 by 2. Constants we have to copy as it is, so we would get this same series. And to expand this gamma n is n gamma n plus 1 is n gamma n, so it is half gamma half. And the same formula applies over here. If I have to find out gamma 5 by 2, I have to write down 3 by 2 into 1 by 2 into gamma 1 by 2. If I have to find out gamma 9 by 2, I have to write down 7 by 2, 3 by 2, 5 by 2 and so on. So like for gamma 9 by 2, this is 7 by 2, 5 by 2, 3 by 2, 1 by 2, gamma 1 by 2. Similarly for gamma 7 by 2, it is 5 by 2, 3 by 2, 1 by 2, gamma 1 by 2 and constants as it is. So when I take out of this whole series, when I take this gamma half upon 2 times s raised to 3 by 2 common, I would get this series, and this series is nothing but the expansion of e raised to minus 1 upon 4s, and gamma half, the value is root pi and its constant is as it is. So this is my final answer. Okay, now let's see the next question, which is if j0 of t is equal to summation r is equal to 0 to infinity minus 1 raised to r factorial the square t by 2 whole raised to 2r, then we have to find out this Laplace of j0 of t. So first of all we will expand this value for 0 till infinity. So first I'll put everywhere in r value is 0, then 1, and I would get this series. I'll just write down 3-4 terms, not more than that. 1 I have to write down the first term, if that is 1 value the 1, then I have to write down, and more than that I have to write down just 3 terms, not more than that, but at least 2 or 3 terms I have to write down. Okay, and when I just simplify this series, I would get this as my answer. So when I have to find out Laplace of j0 of t, I have to take this individual Laplace. Okay, now this Laplace of 1, we would write down Laplace of 1 as 1 upon s, then 1 upon 2 square as it is. Laplace of t square is 2 factorial upon s cube, then 1 upon 2 square into 4 square as it is. Then Laplace of t raised to 4 is 4 factorial upon s raised to 5. Similarly I have to write down the whole series, and I only take 1 upon s common, so remaining terms are this with, and this is nothing but a series of 1 plus 1 upon s square whole raised to minus half, that is equal to 1 upon root 1 plus s square. This is my final answer. Now our next question is find Laplace of error function of root t and Laplace of error function of root t to the base c. So first of all I'll write down the basic formula for error function of t, which you have to remember as it is 2 by root pi integration 0 to t e raised to minus x square dx. So when I have to write down error function of root t, the formula changes only with that t becomes root t and hold the formula as it is. Now when I expand this e raised to minus x square with the series formula, I would get 1 minus x square plus x raised to 4 upon 2 factorial and so on. So when I take integration individual by the normal integration, I am getting this formula. I have to just put the upper and lower limits, but whenever I put lower limit, everywhere it is x, so I would get 0, so only I have to put upper limits, and instead of root t I am writing just t raised to half. Okay, now Laplace of error function of 2t, that means individual Laplace for this all the terms, and as I have explained previously, you have to just expand gamma 3 by 2 as half gamma half, that is half into root pi, so on and so forth. Okay, so individual Laplaces I'll write down then, and from this whole I have already taken 1 upon s raised to 3 by 2 common, and the remaining is, it is 1 plus 1 by s raised to minus half. The whole series is 4. And when I simplify this, what I'm getting, I'll just take LCM, or I'll say cross multiplication, so I would get this answer as root s upon root s plus 1, and outside it was 1 upon s raised to 3 by 2, which is nothing but 1 upon s root s plus 1. Okay, now this is what we have got as Laplace of error function of root t is 1 upon s root s plus 1. Now we have a basic property as error function of x with error function of x to the base c is value 1. So same I can write down for root t also, and now I have to find out error function of root t to the base c, so I can write down it as 1 minus error function of root t. So Laplace of this would be Laplace of these two functions. Laplace of one is nothing but 1 upon s, and as we have found out, Laplace of error function of root t is 1 upon s root s plus 1. Now I would just take cross multiplication and I'm getting this answer, and to simplify this, what I am doing is I am rationalizing the numerator, that is multiplying with the conjugate of numerator and dividing again. So when I simplify this, what I would get, this is nothing but root s plus 1 into root s minus 1, root s plus 1 minus 1 into root s plus 1 plus 1, that is a minus b, a plus b, it is a square minus b square, and then this is common denominator, so s root s plus 1, I mean this is not common denominator, that is by s root s plus 1, and again in bracket this one. So what we can do is 1 upon, see this 1 and 1 gets cancelled, so it is remaining 1 only, and again if I am remaining with s, so s and s again gets cancelled, so I am remaining with 1 upon this root s plus 1 and again this bracket, that is root s plus 1 plus 1. So this is my formula. Error function of c to the base root t is equal to 1 upon root s plus 1 into root s plus 1 plus 1. Okay, now our next question is, if j0 of t is given as this, you have to prove j0 of t as 1 upon root s square plus 1, and hence you have to evaluate this particular integral. Okay, so first of all we'll write down the formula given as it is. Now what we will do is, the integration limit is 0 to pi, so we can write down 2 times 0 to pi by 2. Then we can take Laplace. Laplace means what? 2 by pi integration 0 to infinity. The basic formula is, that is definition formula which we have seen in very first question, e raised to minus st into this whole. Now what we can do, we can just take simply this integration outside and this integration inside, and you have to take just, now this whole means what? It is nothing but integration 0 to infinity e raised to minus st, and this function is nothing but Laplace. So Laplace of this. Now Laplace of cos is what? It is s upon s square plus a square. So we'll apply the formula same over here, and then we will do the integration. Okay, so when we do that same, we'll get this integral, and to simplify this, what we would do, we are just writing this as s sec square theta upon s, like everywhere we are dividing by cos square theta. So 1 upon cos square is nothing but sec square, s square upon cos square is again sec square, and cos square by cos square is 1. So we are getting this as it is now. Then we are just taking sec square minus tan square is equal to 1, that formula we know as a basic formula. So that formula when we apply, we would get s square in like sec square theta we have, so it is 1 plus tan square theta. So s square into 1 plus tan square theta, I would get s square into 1 is nothing but s square only, 1 as it is, and s square into tan square theta is tan square theta. The formula we have used is sec square theta minus tan square theta is equal to 1. So sec square theta is 1 plus tan square theta. And now to simplify this, what we are doing is substitution, that is put s tan theta is equal to t. So we'll just derivate it as it is. Derivative of tan theta is sec square theta d theta dt. When we'll check the limits, when theta is equal to 0, tan 0 is 0, so t is 0. When theta is pi by 2, tan pi by 2 is infinity, the value is infinity. So now, so what we have seen here is like the 2 by pi as it is, then s upon s square cos square theta, and as I have said, what we are doing, we are just dividing by cos square theta everywhere. So I am getting this integral, then I am just explaining. Then what we are doing is, we are putting sec square as 1 plus tan square theta, we are getting this. Then what we have done, we have done just a substitution, s tan theta equal to t. So we'll derivate it, we'll get s square theta d theta is dt. Then when theta equals to 0, I am getting t0, and when theta is equal to pi by 2, I would get t equals to infinity. I would put a value. My new integral is nothing but this one. The formula used, again I am saying, dx upon x square plus a square integration is 1 by a tan inverse x by a. And when I put the limits, I would get this answer. Now, so Laplace is nothing but integration 0 to infinity e raised to minus st, and the function, the value is nothing but this one. Okay. Now what we will do, we will just put value of j0 of t and we'll write down as it is. Now to solve that integral, what we'll do, we'll just put s equal to 1 everywhere, so we will get this value as 1 upon root 2. Now next is what we will say is particular value of the function Laplace of f of t. Now the question is evaluate integration e raised to minus 2t sine cube t. To simplify this sine cube t, because there is no, see, this is nothing but integration, this is not an integration, we have to use Laplace formula only. So there is no formula for sine cube t. So what you have to do is first simplify the sine cube t as, we have formula for sine 3 theta as 3 sine theta minus, see, this is the formula what we have used. Sine cube t is equal to nothing but, I'll just repeat the formula. Sine cube t is nothing but 3 by 4 sine t minus 1 by 4 sine theta, sine 3t. So what is the basic formula? Sine 3 theta is 3 sine theta minus 4 sine cube theta. Okay, that formula we have used over here. Then we will simply find out the Laplaces as it is. Okay. Now we will just put the value of s equal to 2, and as it is given in question itself, it was e raised to minus 2t we have to get. So the value, when you put everywhere s equal to 2, you will get the simply value as 6 by 65. For today, only the last title we will see is change of scale property. That is, if Laplace of f of t is phi of s, then Laplace of f of at is equal to 1 upon a into phi of s upon a. That is, you have to divide just that constant upon in denominator, and you have to replace every s by a. So let's see the question, that is evaluate integration 0 to infinity e raised to minus 2t into error function of 2 root t dt. Okay. So what we have to do, we have to just evaluate this function. So what we'll do, first we know error function of root t Laplace is 1 upon s root s plus 1. So formula says Laplace of f of a t is equal to 1 upon a phi of s upon a. So we have to find out first of all error function of 2 root t. What I'll do, instead of this 2, I'll write down it as root 4. So I'll get whole as root only. So it is nothing but Laplace of error function of root 4t. So it is 1 by a, that is 1 upon 4, because whole function is in root, so I have to just take a, 1 upon s by a. So it is, see, s will be replaced by s by 4, then root s by 4 plus 1. The value is 2 upon s root s plus 4. So integration 0 to infinity, Laplace is nothing but this definition formula, I would get this answer. And when I put s equal to 2 everywhere, because see, in the question itself it is given e raised to minus 2t, so I have to just put s equal to 2. Simply I'll put in s equal to 2, I would get answer as 1 upon root 6. So this is about, or this is all about today's session. This is the part 1 session which we have explained. Laplace I have divided into 2 parts, so second part I'll upload soon. And for the same, also for the previous videos, we have uploaded the Google Drive PDFs. So the link is also given in the description. And I would just request to please like, share and subscribe to our YouTube channel, and stay tuned for the next video. See, in the next video what we are going to see about first shifting theorem, second shifting theorem and so on. So thank you so much for watching the video. Bye. See you.